All right, class. Well, second part of it. I wrote down the next two problems, and we're going to go right away and solve them. So, this problem says almost the same as what we dealt with in the last question, except for it gives you different information. So, you have an open top box. In other words, there's going to be nothing at the top, yes? That has a square base, so I already drew the box. The fact that it has a square base means that the dimensions of the bottom are going to be the same, so I used both an X for the length and the width of it. And it says the volume is 108, so the base is a square, so they get to have the same dimensions, but that doesn't mean the height has to be the same, yes? So the volume of this box is going to be the length times the width, which again, being a square, I'm gonna use the same variable for them, times the height, and I labeled that with y. So, well, we know that this is to be 108 cubic inches, so it's a given value. What you wanna do is you wanna figure out what dimensions should this box have. In other words, what should be x and y in order to minimize the surface area. So what will be the surface area? Well, I'm going to call this one by an 8. And how do we figure out the surface area? Well, where does this box have a surface? Definitely on the bottom. So the bottom is a square, so its surface area is x times x, right? Length times width. The other thing that this box will have is the sides, right? So each of the sides is a rectangle, that's an x by y. And if you think the back surface or the back side is also an x times y, the side surface here is also an x times y, and the front surface is also an x times y, right? The length is always x, the height is y, x times y, right? And so we get 4 of these sides. Now the fact that it's open top, that means I don't have another x squared at the top, right? I just have the bottom and the 4 sides. So the story again goes, as you see, that this here is a function that depends again on 2 variables, and we can't find its minimum or maximum or its derivative for that matter because it's a function of 2 variables. So just like the problem 1 that we just did, I have this extra condition here that tells me how x's and y's are connected to each other. So what I'm going to do again, I'm going to take this equation and solve it for y. So if I solve this one for y, all I have to do is divide by x and x again. So y easily comes up to be 108 divided by this x squared, right? So we divide both x factors from both sides. And what I'm going to do is I'm going to plug it in here for this y. So then the area becomes x squared plus 4 times x times, in place of y, I'm going to put 108 over x squared. And simplifying this, it's going to get me an x squared plus, what happens is one of the x's are going to cancel out, and 4 times 108 should be 432 over x squared. And I'll do some, not over x squared, over just x, right? One of the x's goes away. So, sure enough, this function now depends on 1 variable only. What do I want to do with it? I want to find its minimum surface area, okay? All right, so to find its minimum surface area, what do I do? Well, I'm going to find its derivative, yes, and find the critical numbers. That's where the minimum or the maximum will occur. Okay, so taking this derivative, what would be the best way to take the derivative of this function? I surely don't want to use the quotient rule, so I'm thinking I definitely should be rewriting this function as what? An x squared plus 432 x to the negative 1, right? And now the derivative easily comes up to be 2x minus 432 x to the 1 less than negative 1 is negative 2. Okay. So if I want to find minimums or maximums, I have to set this equal to 0, right? Find the critical numbers. So I'm going to solve this equation easily. It might look a little bit more involved, but sure enough, the easiest thing or the best thing to do would be to move one of each of these terms on one side of the equal. So I'm going to throw this guy over to this side. With fractions, we don't like them, so I'm just going to cross multiply. And I'll get a 2x cubed is equal to 1 times 432, which is 432. Yes. Okay. I'll take this away. Divide by 2. So I'm going to get the x cubed is 216. And sure enough, again, how do I get to x? I will cube root both sides of this equation, and you easily will get that x is equal to 6. 6 cubed is 216. There you go. Solve this, found a critical number. The minimum occurs there. You can easily tell that it's going to be a minimum. I'm not going to go through these steps, and you don't really have to either. How can I tell that this is a minimum? I find the second derivative of it, plug the 6 value in, and if I get a negative number, then it's looking down. That would mean it would be a maximum. If I get a positive value for the second derivative at 6, that means it's a smiley face, right? The function is looking up, so I'm going to have a minimum value. So you can easily check that. I'm telling you it's going to check. You don't have to waste your time. Okay, so x is going to be 6. Let's go and answer the questions. What are the questions? It says, what dimensions? Well, I know that the base should be 6 inches by 6 inches. Yes, we found x to be 6. What else do I need to know? The height. Well, I will plug it in, and the height is going to be 108 divided by 36, which I believe is, I don't know, 3 point something. Let me double check. So what's 108? Oh, 3, yes. So, okay. So 6 times 6 times 3 should get us to 108. All right. What else does it say to find? We found the dimensions, yes? Here they are. What is that area? Okay, so that means I still have to plug this in to actually find the area value. So I'm going to plug that in. So what's going to be the area? Well, the area, we found it to be the area of the base, which is x times x. So 6 times 6 plus 4 times x, which is 6, times y, which is 3. So that's 36 plus 72-ish, I believe. So that should be 108. Oh, how nice. But square inches. It just happened to be the same number. One's cubic inches, the surface area is going to be just square inches, right? Okay. And there's that. Okay. Now, so the last 3 problems that we did would all be what we call geometry problems. We dealt with a box, with a rectangle, with a square. Maybe there'd be problems about cylinders or whatever they are. Anytime you deal with a geometry problem, it really is helpful to draw yourself a picture. Write down what you know. Write down what you have to find out. Well, and take it from there. Okay. Now we're getting finally into the business ones, the good ones. Many times in these problems, you'll see we're going to be dealing with cost, revenue, and profit. So, sure enough, let's read this. It says the price for a guitar is, the cost function is, find the number of guitars and the price that has to be charged to maximize profit. So I'm going to start right there. How do we find profit? Well, profit was what? Revenue, how much money you're making, minus the cost, how much money you are spending. Well, the cost function is given to us. We don't have to come up with it. In other examples, we will have to come up with a cost function as well. But the revenue is what we need to come up with. So, how do you make money? Well, you make money by selling things. What are we selling? Some number of items, yes, which in this case is our guitars, times whatever we're selling them for. So, price per guitar, right? We might sell 10 guitars at $400 each. There you go. You made $4,000. Okay. Minus that cost function. Okay, so how many guitars are we selling? Well, it says we're going to make X. What is the price at which we're selling these guitars? The price is a given function, so it's not a fixed price. That happens many times. The more you buy, the less we are charging you per item. So what this price function here says is that, fine, we're starting at $400 per guitar if you sell none of them, or if you buy none of them. If you buy one guitar, we're going to charge you $3.99 each. If you buy two guitars, we're going to charge you $3.98 per guitar. So the more we buy, the less we make the price per guitar be. And that happens many times. Buying in bulk will cost you less per item. Okay? Minus the cost function. So I will copy all of this down. That's going to be 400x minus x squared minus, what's the cost function? I'm taking it straight from here. That's 100x. And don't forget to distribute the minus. So that's minus 3,000. So sure enough, the profit function that we are supposed to do what? Maximize is negative x squared plus 300x minus 3,000. How do we find a min or a max? Take the derivative, which is negative 2x plus 300. Set it equal to 0. Find your critical number. X is easily 150 out of this. There you go. We solved the problem. So, again, find the second derivative, which is a negative 2. Negative means a sad phase. That gives you a maximum. Sure enough, we're asking you for a maximum. We're done talking about the second derivative. We don't need to check up on that every time. If it says maximize it, the answer will maximize it. If it says minimize it, the answer will indeed minimize your problem. So, what do I have to do? It says, find the number of guitars. Well, we found it. 150 guitars should be sold. The price that will maximize the profit. What's the price? The price is 400 minus X. So in other words, sell them at $250 each. Okay? And finally, find the maximum profit. Well, so the last part of it is take this X value and plug it into the profit function. So you can put it in here. Look at that. We came up with this profit function right here. Plug in 150. Oh, I don't know. I'm just going to check really quick what the answer is. I don't really want to do the math. But if you plug this 150 into the profit function, apparently you're going to get a total of $19,500. $19,500. Ta-da! I'm going to stop it because these